the required temperature for a proper casting. You can't pour metal this hot into a metal mold. The mold would just melt. So instead, the factory uses damp sand. Sand withstands intense heat by absorbing it. The machine forms the molds much the way you'd use a pail to form a sandcastle. It first constructs the bottom half of the mold. This filter will screen out any slag particles the molten metal may still contain, and these cores create empty spaces within a part. Now the machine forms the top half of the mold. They slip a weighted metal jacket around the finished sand mold. This keeps it from collapsing under the weight of the metal. Workers fill the molds right to the top. It takes from 30 to 45 minutes for the molten metal to solidify. They remove the weighted metal jacket, then dump the mold into what's called the shakeout. The vibration breaks the sand mold apart, releasing the metal pulleys. While the pulleys go off to be cleaned, the sand is recycled into new molds. The pulleys are in rough form. They still have to be machined to specifications. A robot places each one under a computerized camera. A visual recognition program guides the robot to position the pulley properly in the various automated tooling machines. The first machine makes the pulley's grooves. The next machine will drill holes in the hub for installing the screws. At the end of the machining process, a gauging system takes precise measurements and guides the equipment to correct any errors. This is a two-part pulley known as a variable pulley because it can run a belt at variable speeds. This tooling machine performs several operations on the male component. It machines the face and outside diameter on one side, then flips the pulley over to make the bore and threads on the other side. The last operation drills holes for two screws that will affix the pulley to the shaft of the electric motor. A touch of lubricant, and the next machine assembles the male and female parts. After setting the proper speed, the user locks the parts in position with a screw. Many industries use rubber hose in their day-to-day operations. Sometimes they use it to remove water or evacuate waste, or to supply certain machines in the factory with air or water or raw materials. For instance, food producers might feed ingredients through a rubber hose into a mixer. This company makes low-pressure and medium-pressure rubber hoses. The intended use is what determines the rubber composition. Function also determines the color because industrial hoses are often color-coded. The rubber arrives at the factory from the supplier in rough strips. The first step is to run it through a mill. The rollers heat the rubber, softening and smoothing it to an even texture. The next machine cuts the rubber in strips to the precise width and thickness required for the size of hose they're going to construct. Workers lubricate a steel mandrel that's the exact size of the hose's bore. As the mandrel spins, they wrap a rubber strip around it, measuring and layering if necessary to build the thickness they're after. Next, they add one or more reinforcement layers. This strip is made of a high-strength synthetic fabric that's been coated in rubber. It's designed to withstand the pressure to which the hose will be subjected. The last layer of rubber forms the hose's outside covering. After verifying that the final diameter is correct, they wrap the entire hose construction tightly in wet nylon tape. The tape will later shrink and compress all the materials together. This factory also makes hoses with a built-in attachment on the end. They position it on the mandrel, then glue the first layer of rubber to it. Then they reinforce the bond with special textile strips and tightly wound high-strength carbon steel wire. They continue the wire more loosely down the body of the hose at a specific angle designed to withstand vacuum pressure. Then they wrap the hose in a soft, stretchy rubber strip that fills the gaps between the wires. Next comes a layer of high-strength rubber-coated fabric. Then finally, the exterior covering, light blue rubber for this model. They pressure wrap again with wet nylon tape. Then, to make the hose more flexible, they create corrugations by wrapping it tightly in rope. What's under the rope compacts, creating a dip. They add another layer of nylon tape to hold the rope in place. When construction is finished, the hoses on their respective mandrels go into an autoclave, a cylindrical chamber into which they feed hot steam at high pressure. This vulcanization process, as it's called, triggers a chemical reaction that cures the rubber, making it elastic. Once the hoses come out and cool, workers remove the shrunk tape. The layers are solidly compressed. They wash the nylon tape, then rewind and reuse it. Now workers begin the process of removing the hose from the mandrel. They tie one end with a rope to create pressure, then gently pump water between the mandrel and rubber. The lubricant they applied earlier has prevented the rubber from sticking to the steel, so the hose separates easily. They simply slide it off the mandrel.